Hi, we have the AP Physics 1 past paper 2021. We are discussing the free response question section. We have question number 3 which carry the 12 point. In this question, a student of mass M standing on a smooth surface uses a stick to push the disk of mass MD. The student exerts a constant horizontal force of the magnitude Fh over the time interval from time t0 to tf. While pushing the disk, assume there is a negligible friction between the disk and the surface. Okay, this is the info provided. Now question is, assuming the disk begin at rest, determine the expression of final speed Vd of the disk relative to the surface. Express your answer in term of Fh, Tf, Ms and Md with physical constants and appropriate. Okay, this is a question for 1 point. Now we have to know F is equal to Ma. Now we have Fh horizontal force applying Md this mass of the disk, Ad acceleration of the disk. So acceleration of the disk can be written Ad is equal to Fh over Md. Now from equation of motion Vf is equal to Vi plus At, we apply it to it disk. Final velocity of the disk is Vd. Initially disk is at the rest, so its initial velocity is 0. Acceleration is Ad, or after time t, Tf it is. So Vd can be written from value of Ad we can place here. So Fh over Md into Tf. So this is the velocity of final velocity of the disk after Tf time. Now next question. Assume negligible friction between the student shoes and the surface. After time Tf, the student slides with the speed Vs. Derive the equation for the ratio Vd over Vs. Express your answer in terms of Ms, Md and physical constant as appropriate. Okay, now there is a two body system. One is the student, one is the disk. So using the law of conservation of momentum, initial momentum is the 0. Final momentum is ms for the mass of the student, vs because there is a opposite reaction, minus vs the velocity of the student, md plus vd mass of the disk and velocity of the disk. So this can be moved to other side with positive sign. So there is a ratio over Vd over Vs that can be written Ms over Md. Inversely proportional to their velocities, there is a ratio. So that's the answer. Now next part of the question is, assume the student mass is greater than the mass of disk. Ms is greater than Md. On a grid below, sketch the graph of speed of both student and the disk as a function of time between t0 to t2f. Assume neither the disk nor the students collide any other after tf. On the vertical axis, Vd and Vs label the graph S and D for the student and disk respectively. Okay, now we draw the graph. Okay, you can see there is a student v 0 to tf, there is a force. So there is a constant force, so there is a constant acceleration. For constant acceleration, velocity is increasing uniformly. So after that there is a no force, because it's openly said there is a neither disk student glide after ttf. There is no contact or there is no force, so there is a no external force. Acceleration is 0. When acceleration is 0, velocity is constant. So you can see there is a constant velocity for both objects, disk and the students. Now why the disk velocity is greater than the student velocity? Because the mass of the student is greater than the disk. So we have proved here that mass and velocity are inversely related. So when mass is greater, velocity is less. Disk accelerate more because smaller mass. When accelerate more, there is a more change in velocity of the disk, as so there is a more steeper curve for the disk as compared to the student. So that's the explanation of the whole graph. Now next, the next part, the disk is now moving with the constant speed vi on a surface toward the block of mass mb, which is at the rest on a surface as shown in a fig. The disk collide head on and stick together. Center of mass, the disk block system move with the speed vcm. Now the question are about these two systems. Now mass of the disk is much greater than the mass of the block. Estimate the velocity of center of mass disk block system. Explain how you arrive your prediction without driving it mathematically. So answer is center of mass almost will move with the velocity which carrying the disk, because v1 is the velocity of the disk while the block is at rest position. So I have written the center of mass has the same velocity as the almost same velocity as the disk. Now explanation why this is the answer, because the much heavier disk when hit with the lighter body which is at the rest, heavy disk motion barely affected. Lighter block doesn't have enough mass to slow down the disk noticeably. It's just like the disk pick up light body and keep going almost with the same speed. So the system continue move almost if there is only disk existed. That's the reason it's there is a no effect of the block on the motion of the disk. Now question change. Mass of the disk is less, much less as the block mass of the block. Estimate the velocity of center of mass of the disk block system. Explain how you arrive your prediction without driving them mathematically. Now I have provided the center of mass is almost velocity of the center of mass is almost zero, because the block is at rest when it is much heavier as compared to the disk. So lighter disk hit and stick much heavier block at rest. The heavy block barely moves. The center of mass stay where almost the heavy block is. The combined system almost rests because heavy blocks dominate. He barely move. Okay, that's the reason there the velocity of center of mass is almost zero. Now the question, now suppose neither object mass is much greater than other but they are not necessarily equal. Drive the equation for the center of mass. Express your answer in terms of V1, MD, MB. Use physical constants as appropriate. Okay, by using the law of conservation of momentum, initial momentum should be equal to final momentum. So initially the only disk is moving, block is at rest, MD into V1. After that they stick together, MD plus MB, their whole mass with the center of velocity of center of mass VCM. So VCM is can be written MD V1 over MD plus MB. So this is the equation for the center of mass. Now question is, you consider the scenario from C1 where the mass of the disk is much greater than the mass of the block. Does your equation for center of mass in part C3 agree with the equation reasoning in the part C1? Then answer is should be yes or no. Explain your reasoning by addressing why according to your equation center of mass become or approaches certain value when MD is much greater than MB. Okay. Now answer is the first of all yes. Now reasoning, we have to know MD is much greater than the MB. Disk mass is much greater than the block mass. So we have derived the relation of center of mass MD into V1 over MD plus MB. We neglect the factor MB because it is negligible. So the equation can be approximately written MD V1 over MD. This MD can be cancelled, so approximately is equal to V1. So this matches the estimate we have concluded in the past C1 where the system moves nearly velocity V1. So that's the answer. If you have any query, kindly ask in the comments. If you like the content, kindly subscribe and share with your friends. Okay, take care.